Dear students, today we are discussing about P block elements. In the P block elements, we are going to discuss about the oxides and oxy acids of 6th A group elements and 7th A and other group elements. Okay. So, in previous class, I explained about what is the oxides and what is the difference between oxides and oxy acids. Oxides means the group elements when react with oxygen gives oxides. Okay. So, now come to 6th A. For example, you take boron family, 3rd A group elements. The boron family when react with oxygen gives trioxide, for example, B2O3 and Al2O3 like this. Boron trioxide and aluminum trioxide like this. And you take 4th A group element in the P block elements, the carbon, silicon, germanium, tin, lead. The 4th A group elements when react with oxygen gives dioxide. The general formula is MO2. Example, in place of M, you have to substitute C, CO2, SiO2 like this. Carbon dioxide and silicon dioxide, selenium dioxide, tellurium dioxide, right? And you go to 5th group elements, nitrogen family, the nitrogen, phosphorus, arsenic, antimony. These elements when react with oxygen gives majorly 2 types of oxides are formed. One is trioxide and pentoxide. The formula is M2O3 and another formula is M2O5. M2O3 is called trioxide and M2O5 is called pentoxide. N2O3, P2O3, like arsenic As2O3, Sb2O3 like this. And you come to pentoxide, the general formula is M2O5, the best example. So, N2O5 and P2O5, As2O5 like this, right. So, you remember here the nitrogen cannot form pentoxides because of the it is a small size and not available in the d orbitals. So, that is why the nitrogen cannot having the 5 valency state. But here the nitrogen, due to the special more electronegativity, the nitrogen not only the 2 oxides, it can form another 3 oxides also. The total 5 oxides are formed here, N2O, NO, N2O3, N2O4, N2O5. But the phosphorus, arsenic, antimony, always they give only trioxide and pentoxides, right. So, this is the reason. And bismuth does not form pentoxides because due to inert pair effect. Jada electron janta prabhavam moolanga bismuth only trioxides maatrame form chestundi. So, this is the 5th group elements oxides. You come to 6th group, for example, sulfur, selenium, tellurium. These group oxides when dissolved in water, so these group elements when react with oxygen gives 2 types of oxide. One is di and second one is trioxide. The dioxide formula MO2 and trioxide formula MO3. The best MO2, the best example SO2, SeO2, TeO2 like this. MO3, in place of M, you have to substitute sulfur, selenium, tellurium like this, SO3, SeO3, TeO3 like this. Okay. So, these are the 2 oxides. And you come to 7th A, the halogens like fluorine, chlorine, bromine, iodine when react with oxygen. So, they gives different monoxides, dioxide and hexoxide and heptoxides. The best example, Cl2O, chlorine monoxide, ClO2, chlorine dioxide, Cl2O6, chlorine hexoxide, and Cl2O7, chlorine heptoxide. So, the 7th halogen groups, the big size elements except fluorine, the remaining chlorine, bromine, iodine can form the the more oxides like monoxides, dioxides, hexoxide and heptoxides. But in case of fluorine is a small size, not available in the d orbitals here. That's why the fluorine when react with oxygen gives two types of oxides only. One is OF2 and second one O2F2. OF2 means oxygen difluoride and O2F2 means dioxy difluoride. So, two types of oxides. You come to p block elements. So, you come to noble gases, zero group elements like xenon. When the xenon react with oxygen, it gives xenon O3 and xenon O4, xenon trioxide and xenon trioxide. So, now you see third A2 zero group elements. ఇందాక మీరు చూసారు కదా థర్డ్ ఏ గ్రూప్ నుంచి నోబుల్ గ్యాసెస్ వరకు ప్రతి గ్రూప్ ఎలిమెంట్స్ ఆక్సిజన్తో రియాక్ట్ అయ్యి బేస్డ్ ఆన్ ద ఆక్సిడేషన్ స్టేట్ డిఫరెంట్ ఆక్సైడ్స్ అన్నీ కూడా ఎగ్జిబిట్ చేస్తాయి. రైట్, ఇందాక బోరాన్ చూసాం, అల్యూమినియం, ఫోర్త్ గ్రూప్లో కార్బన్, సిలికాన్, ఫిఫ్త్ గ్రూప్లో నైట్రోజన్, ఫాస్ఫరస్, సిక్స్త్ గ్రూప్లో ఆక్సిజన్, సల్ఫర్ అండ్ సెవెంత్ గ్రూప్లో ఫ్లోరిన్, క్లోరిన్, బ్రోమిన్, అయోడిన్ and noble gases లో xenon. So, these are all elements when react with oxygen gives different oxides. So, ఈ ఆక్సైడ్లను మనం ఫస్ట్ ఫార్ములాస్ ఫైండ్ అవుట్ చేసాం. Then we go to the nature. When dissolved in water, what happened? That is the one point. And second one, the oxides structure. That is second important. And another important one is geometry and hybridization. How many lone pairs, how many bond pairs are present around the central atom, also important for examination point of view. Suppose you take oxides of sulfur, you take sixth group element, the SO2, right, the sulfur dioxide. So, you see this is the structure of SO2, SO2. The central sulfur bonded with two oxygen atoms. One is double bond O and this is coordinate covalent bond. The sulfur valency is 6 electrons. Out of the 6, 4 electrons are participated with two oxygen with oxygen, two oxygen atoms. So, 4 electrons are participated with the 2 oxygen. The remaining 4 electrons are available on central atom, that is called non-bonding electrons. Therefore, around sulfur 2 lone pairs, 2 sigma bonds are present here. So, 2 lone pairs, 2 sigma bonds, total 2 plus 2, 4, 4 means the central atom like sulfur exhibit sp3 hybridization. But the geometry due to lone pair repulsions, the geometry exhibiting V shape or angular form, right. So, the sulfur dioxide having sp3 hybridization and geometry is V shape, right. So, this is the structure, hybridization completed and the structure also completed. Now, lone pairs, how many lone pairs are present in central atom? So, non-bonding electrons are called lone pairs. These electrons does not involve in the bonding. They are available on central atom only. That type of electrons are called N electrons or non-bonding electrons or lone pairs. Ela anna kuda okate. Okay. The electrons, you remember any molecules, two types of electrons are there. One is bonding electron, second one non-bonding electrons. Bonding means whether it is participating in the bonding with terminal atoms. They form whether sigma or pi bond. Some electrons does not involve in the chemical bonding in the other atoms. They are available on central atom. That type of electrons are called non-bonding electrons, or generally we call N electron. N means non-bonding electrons. In case of SO2, the central atom having 2 lone pairs, that means 4 N electrons, and remaining 4 electrons are participating with 2 oxygen atoms. So, this is the information about SO2. You can apply any molecule, any oxygen like boron trioxide, aluminum oxide and carbon dioxide, nitrogen oxides, phosphorus oxides, sulfur oxides, chlorine oxides or xenon oxides. You take any oxides, you are explained like this. The central atom, how many lone pairs are present, how many sigma bonds are present, how many pi bonds are present. These three characters are important, and one more character, the central atom oxidation state also. For example, you take SO2, the sulfur oxidation state is +2. So, +4, each oxygen -2. Here 2 oxygen atoms are there, -2, -2, -4, the -4 going to right side, +4. Therefore, in SO2, the sulfur exhibiting +4 oxidation state, right. One is number of sigma bonds, and second one number of lone pairs, and third one hybridization, and fourth one geometry, and fifth one oxidation state. The 5 characters are important around the structural information of any oxide. You take from 3rd A to 8th A. So, all oxides you go through like this. Okay. Now, this is the information about SO2. And SO3 also same. The SO3 means the SO3, the sulfur having 6 electrons, the 6 electrons participating and bonding with the 3 oxygen atoms. So, around the sulfur 3 double bonds are formed here. The each double bond containing 1 sigma, 1 pi. One single bond means sigma, the double bond means the double bond containing 1 sigma, 1 pi, the triple bond containing 1 sigma and 2 pi. In case of SO3, the sulfur around the sulfur, 3 double bonds are present here, each double bond containing 1 sigma, 1 pi. For going to hybridization, we have to consider only sigma bonds. మనం hybridization చెప్పాలి అంటే సిగ్మాలు మాత్రమే కన్సిడర్ చేస్తాము. సో దేర్ ఫోర్ SO3లో sigma bonds 3 and pi bonds 3. We have to consider only sigma, that's why 3 sigmas are present around sulfur in SO3, and there is no lone pairs because of 6 electrons are participating in the 3 oxygen atoms. So, 0 lone pairs, 3 sigmas, 3 plus 0, total 3, 3 means sp2 hybridization, right. So, the SO3 molecule exhibiting sp2 hybridization, and geometry is a trigonal planar, samatala tribujamu ఉంటుంది. So, SO2 and SO3 both are exhibiting sp2 hybridizations, and geometry SO2 is V shape and SO3 is trigonal planar. The SO3 in SO2 the SOOS is +4, in SO3 the sulfur OS is 6, each oxygen -2. So, -2 into 3 -6 going to right side +6. So, this is the information about oxides of sulfur, like here, that is called dioxide and trioxide. You can apply any dioxide, for example, sulfur, other oxides also the same situation around central atom. You can calculate sigma and lone pair. We can explain about hybridization and geometry and number of sigma, number of lone pairs, number of n electrons. What about the OS, oxidation state of central atom? So, these are the information about the oxides. Now, come to the next one, very important one is oxy acids. Just now I told you, and previous class I told you, oxy acids means any oxide in the p block elements. You come to, for example, 3rd A, boron family to halogen family, 7th A. So, any oxide when dissolved in water, అవి వాటర్లో కరిగించినప్పుడు ఏర్పడే కాంపౌండ్స్ను ఆక్సీ యాసిడ్స్ అంటారు. So, that is the one point. And you come to first family, boron family, 3rd A, you take boron B2O3, boron trioxide, when dissolved in water, they are producing boric acid. The B2O3 plus H2O gives H3BO3. H3BO3 అనేది ఫామ్ చేస్తుంది, రైట్. అలానే you take 4th family, carbon. The carbon oxide, most important oxide is CO2. CO2 is a acidic oxide. The CO2 when dissolved in water, they are producing H2CO3, carbonic acid. So, CO2 plus water gives H2CO3. So, you remember boron trioxide gives boric acid and carbon dioxide gives carbonic acid, H2CO3. You come to nitrogen family, The nitrogen oxides are 5 types. Out of the 5, the last 3 oxides are acidic oxides, right? So, N2O2, N2O3, N2O4, N2O5. These 3 oxides, when dissolved in water, they are producing mainly 2 types of oxides. One is HNO2 and second one HNO3, right? So, the oxy acids of nitrogen, basically directly 2 oxides are important, but indirectly 4 oxides also there. One is hyponitrous acid H2N2O2, nitrous acid HNO2, nitric acid HNO3 and fernitric acid HNO4. Okay? The 4 oxy acids are available, that's the nitrogen oxy acids. Okay? This is and the second one, you take the same group, phosphorus also. The phosphorus oxides are basically 2 types, phosphorus trioxide, phosphorus pentoxide. The formula is P2O3 or P2O4. The P2O3 is a monomeric state, but the P2O3 available in dimeric state also, P4O6 and P4O10. So, they are dioxide, trioxide and pentoxides. These 2 oxides of phosphorus dissolve in water, they are producing many oxy acids. They are called phosphorus oxy acids. Orthophosphorus acid, H3PO3, famous oxy acids of phosphorus. Orthophosphoric acid, H3PO4, metaphosphoric acid, HPO3, hypophosphorus acid, H3PO2, right? Peroxyphosphoric acid, H3PO5, like this. So, these are all the oxy acids of phosphorus. ఓకేనా? ఇప్పుడు మీకు అర్థమైంది కదా, ఆక్సిడైజ్ ఫాస్ఫరస్ అంటే ద ఫాస్ఫరస్ ఆక్సైడ్లు వాటర్లో డిజాల్వ్ అయినప్పుడు ఇన్ని రకాల యాసిడ్స్ని ప్రొడ్యూస్ చేస్తాయి. దే ఆర్ కలెక్టివ్లీ వి కాల్డ్ ఆక్సీ యాసిడ్స్ ఆఫ్ ఫాస్ఫరస్. నౌ కమ్ టు ద ఆక్సీ యాసిడ్స్ ఆఫ్ సల్ఫర్. ఇది మనం ఇప్పుడు డిస్కస్ చేద్దాం. ఓకేనా? సో సల్ఫర్ ఆక్సైడ్స్ ఇందాక చెప్పాను, బేసికలీ 2 ఆక్సైడ్స్, SO2, SO3. These SO2, SO3, these are when dissolved in water. అవి నీళ్ళల్లో కరిగించినప్పుడు మనకి ప్రధానంగా 10 టైప్స్ ఆఫ్ ఆక్సీ యాసిడ్స్ ప్రొడ్యూస్ అవుతాయి. ఇది మనకు ఎగ్జామ్లో కూడా చాలాసార్లు ఈ క్వశ్చన్స్ అడుగుతుంటారు. రైట్ ద ఆక్సీ యాసిడ్స్ ఆఫ్ సల్ఫర్. దిస్ ఇస్ ద క్వశ్చన్, లైక్ డిడ్ ద టైప్ ఆఫ్ క్వశ్చన్స్ దట్ వీఆర్ ఎక్స్పెక్టింగ్ ఇన్ కమింగ్ ఎగ్జామినేషన్ పాయింట్ ఆఫ్ వ్యూ. సో రైట్ ద ఆక్సీ యాసిడ్స్ ఆఫ్ సల్ఫర్. Mainly the sulfur oxides, when dissolved in water, they produced the following oxy acids. The first one is us acids, the second one is ic acids, and third one is thionic acids, and the fourth one is peroxy acids. The 4 groups are formed here. The total oxy acids of sulfur we can classify it into 4 categories. Us means the suffix sound is us, sulfurous. The formula is H2SO3, sulfurous acid. Ic acid, if the more oxygen containing, the type of oxides are ic acids. H2SO4, the name is sulfuric acid. Thionic acid, more sulfur. If the oxy acid containing more sulfur, the type of acids are called thionic. Thio means sulfur. One sulfur is normal sulfur. If the same compound containing more sulfur, that is called thionic sulfur. You remember any acids, all of you listen carefully. The condition is the acids are basically 2 types. One is us acid, second one ic acid. ఇది గుర్తుపెట్టుకోవాలి, ఎగ్జామ్ చాలాసార్లు ఇది కన్ఫ్యూజ్ అవుతుంటారు. us means if the acids are containing less oxygen is called us acid. If the acids are containing more oxygen is called ic acid. The best example, you take nitrogen. The nitrogen oxy acids are 2, HNO2, HNO3. HNO2 oxygen atoms are there, that is called us acid. HNO3, more oxygens are available here, that is called ic acid. So nitrous, nitric. You remember nitrous, us means less oxygen, ic means more oxygens are available. The same way you come to here sulfur oxy acids also, sulfurous acid, sulfuric acid, H2SO3, H2SO4. right? So these are the oxy acids. You see the sulfur, the following acids: sulfuric acid, sulfurous acid, sulfuric acid, thiosulfurous acid, thiosulfuric acid, pyrosulfurous acid, pyrosulfuric acid, and the last category, most important, peroxy acids, means this type of oxy acids of sulfur containing peroxy bond. Peroxy bond means, already in the previous class I told you, OO bond, the acids containing OO bond, that is called peroxy bond. These are the two types: peroxy monosulfuric acid and peroxy disulfuric acid. The formula is H2SO5 and H2S2O8. The H2SO5 is called peroxy monosulfuric acid and H2S2O8 is called peroxy disulfuric acid. Right? These two acids are containing peroxy bond. Peroxy means OO bond. OO bond is containing acids are called peroxy acids. So the sulfur oxy acid, out of the 10, the 2 acids comes under this group, peroxy group, right? So peroxy monosulfuric is called, generally we call Carose acid, the common name is Carose, and peroxy disulfuric is called, generally we call Marshall acid. So sometime in exam entrance point of view, they are asking like this question: which of the following is a Marshall acid and which of the following is a Carose acid? Which of the following is a peroxy bond acid? This type of questions we are expecting for competitive examination point of view as well as theory examinations also. And the next one, you come to the famous, out of the 10 acids, the first one, sulfuric acid, H2SO4, generally we call king of the chemical. వాటిని సాధారణంగా మనం ఏమంటామంటే రసాయనాల రారాజు అంటారు. మీన్స్ every chemical reactions we have to using this acid. That's why this acid we have to using all chemical reactions. Generally we call, the common name is king of the chemical. So రసాయనాల రారాజు అంటారు, H2SO4. So in H2SO4, the central atom sulfur containing 2 OH bonds and 2 double bond O bonds. So the S double bond O bonds are 2 bonds and SOH bonds are 2. So around sulfur, just now I told you, around sulfur 4 sigma bonds and 2 pi bonds are present here. For going to hybridization, we have to consider only sigma. That's why around sulfur 4 sigma bonds are present here. There is no lone pairs. So 4 plus 0, 4. 4 means sp3 hybridization. So therefore, in sulfuric acid, the central sulfur exhibit sp3 hybridization because of 4 sigma bonds are present here, no lone pairs, 0 lone pairs around sulfur, and the geometry is tetrahedral and bond angle 109 degrees 28 minutes. So this is the structural information about sulfur in sulfuric acid. The same way you follow the remaining acids also. Sulfurous acid, thiosulfuric acid, like this. For example, you see this type of acid. This is thio. Here the bonds you see, all of you, SS bond present here. The before acid you see this is SOH bond and S double bond O bond present here. You come to this acid, SS bond, S double bond O bond is, and every acids of sulfur containing the following bonds. One is SO bond, SOH bond, SS bond. So you remember this type of bonds also, the observation also very important here. And this acid, this one is here only SOH bond and SO bonds are present here. Now the famous acid, you see this one, this is called, this acid is very important, pyrosulfuric acid. Pyro means 7, pyrosulfuric H2S2O7. Generally we call fuming sulfuric acid. అంటే దీన్ని ఏమంటున్నానంటే ఫ్యూమింగ్ సల్ఫ్యూరిక్ యాసిడ్ మీన్స్ పొగలు గక్కే సల్ఫ్యూరిక్ ఆమ్లం అంటారు. సో ఫ్యూమింగ్ సల్ఫ్యూరిక్, జనరల్ అనదర్ నేమ్ ఆల్సో దేర్, ఓలియం. The 3 names are present here. One is oleum and fuming sulfuric acid, and third one pyrosulfuric acid. So what is the specialty of this acid means, you see all of you the structure, this acid containing bridge bond. So 2 sulfurs connecting with oxygen atom. That bridge is called SOS. This is connecting link with oxygen. The oxygen is a bridge. So that's why which of the following acid containing bridge bond? This type of questions also we are expecting for coming entrance examination point of view. So out of the 10 oxides of sulfur, one oxide containing bridge bond, that is called pyrosulfuric acid. The formula is H2S2O7. The H2S2O7 structurally, the connecting in between two sulfurs, the oxygen atoms also there. So this is the pyrosulfuric acid information. And the last combination, just now I told you, peroxy bonds, peroxy acids. The peroxy acids are two types, peroxy mono, peroxy di. You see, this is the structure of peroxy mono. The OO bond present here. Okay, so this is peroxy bond, OO bond, around sulfur, OH bond present here, S double bond O present here, and peroxy bond here. And peroxy mono and peroxy disulfuric acid. Here two sulfurs in between the peroxy OO bond present here, and it is a dibasic acid because two OH groups are present here. So it is a dibasic acid and containing one peroxy bond, containing 4 SO bonds and containing 2 SOH bonds. So this is the structural information, and each sulfur, the common hybridization is sp3 because of 4 sigma bonds are present here, and each sulfur exhibiting +6 oxidation state because of, you see all of you, and this oxygen is -1 and this oxygen is -1 and this oxygen shows -2 and this oxygen shows -2. So therefore around sulfur -6, the -6 going to right side +6. That means the peroxy disulfuric acid, the two sulfurs are exhibiting +6 oxidation state. The left side sulfur +6 and right side sulfur +6. The two sulfurs average +6 plus +6 by 2, nothing is equal to 6. So average the sulfur oxidation state is 6. So this is the structural information about the oxy acids of sulfur, right? And you come to the properties of sulfuric acid. It is additional information, and these are the model questions about 6th group elements. What type of questions we are expecting in competitive examinations after completion of BSc. You go to, for example, PG set examinations or CU set examinations, or some students are appearing JAM and examination, IIT examination point of view. So the multiple choice questions we are expecting for competitive examination point of view. So every student and must and should learn about the group information. The group information, like any group from S black or P black or D black, the group information very important. The group information means you first you go to, you take any group, first you draw the elements, you write the elements identification of the group position in the periodic table. First one, you draw the periodic table, and then you have to identify the group. Then go to the properties. The properties are physical property and chemical properties. The physical property means what type of property comes under physical, that is important. The periodic properties also comes under physical properties. Then go to chemical properties. The chemical property I told you already, the hydrates, halides, oxides, oxy acids. So this is the outlines information about the each group. We have 18 groups in the periodic table, S black, P black, D black. You take any group, especially in examination point of view, in semester point of view, S block, P blocks are important. In our syllabus, the P block elements are there. The P block containing 6 groups, 3rd A to 8th A. So 3rd A to 8th A, you follow this information, very important. Then ultimately you can learn easily. ఒక గ్రూప్ను చదవాలి అంటే ఇలా మనం ప్లాన్ చేసుకుంటేనే గ్రూప్ యొక్క ఇన్ఫర్మేషన్ మనకు వస్తుంది. అదర్వైజ్ మనం కన్ఫ్యూజ్ అవుతాం. కాబట్టి ఒక గ్రూప్ను మనం నీట్గా ప్రజెంట్ చేయాలి అంటే వాటి యొక్క ప్రాపర్టీస్ క్లియర్ రావాలి, వాటి ఎలక్ట్రాన్ కాన్ఫిగరేషన్ ఏంటో తెలియాలి, లొకేషన్ ఎక్కడో తెలుసుకోవాలి, అండ్ ప్రాపర్టీస్ కూడా సిస్టమేటిక్గా మనం ఫాలో అవుతే ఒక గ్రూప్ యొక్క ఇన్ఫర్మేషన్ మీరు కరెక్ట్ క్లారిటీ తెచ్చుకుంటే ద సేమ్ రిలేషన్స్ యూ కెన్ అప్లై అదర్ గ్రూప్ ఆల్సో. ఇది ఎలా ఉంటుందో లింక్, అదే లింక్ అదర్ గ్రూప్లో కూడా ఉంటుంది. కాబట్టి ఫర్ ఎగ్జాంపుల్ ఒక 3rd A గ్రూప్ స్టడీస్ కనుక డీటెయిల్ కనుక రీడ్ చేస్తే ద సేమ్ ప్రిన్సిపల్ యూ కెన్ అప్లైడ్ ఇన్ 4th A, 5th A, 6th A, 7th A. కాబట్టి ఒక గ్రూపును క్షుణ్ణంగా అంటే క్లియర్గా మనం చదవాలి. ఎలా అంటే ఇందాక నేను చెప్పినట్టుగా ప్రాపర్టీస్ డివైడ్ చేసుకోవాలి. అన్నిటికంటే ముందు ఆ గ్రూప్ ఎక్కడుందో ఐడెంటిఫై చేయాలి, గ్రూప్ ఎలిమెంట్స్ మీకు రావాలి, ఎలక్ట్రాన్ కాన్ఫిగరేషన్ మొత్తం క్లియర్ రాయాలి, దెన్ ప్రాపర్టీస్ ఐడెంటిఫై చేయాలి. అందులో ఫిజికల్ ప్రాపర్టీస్, పీరియాడిక్ ప్రాపర్టీస్, కెమికల్ ప్రాపర్టీ డివైడ్ చేసుకొని ఆ తర్వాత వాటి యొక్క స్ట్రక్చరల్ ఇన్ఫర్మేషన్, సో ఆక్సైడ్ యొక్క స్ట్రక్చర్, హాలైడ్ యొక్క స్ట్రక్చర్స్, ఆక్సీ యాసిడ్స్ యొక్క ఫార్ములాస్ అండ్ స్ట్రక్చర్స్ ఒక సిస్టమాటిక్ వేలో కనుక మీరు ప్లాన్ చేసుకుంటే 8 గ్రూప్స్, 6th గ్రూప్లో 6 గ్రూప్స్ ఇన్ P బ్లాక్ ఎలిమెంట్స్ అండ్ రిమైనింగ్ 2 గ్రూప్స్ ఇన్ S బ్లాక్ ఎలిమెంట్స్ అంటే టోటల్ 8 గ్రూప్స్ మీకు కమాండింగ్ వస్తుంది. సో అల్టిమేట్గా S బ్లాక్ అండ్ P బ్లాక్ మనకు ఫినిష్ అవుతుంది. సో ఈరోజు మనం టుడే వీఆర్ డిస్కసింగ్ అబౌట్ ఆక్సైడ్స్ అండ్ ఆక్సీ యాసిడ్స్ ఫ్రమ్ P బ్లాక్ ఎలిమెంట్స్ లైక్ 3rd A2 అండ్ 7th A వరకు మనం డిస్కస్ చేసాం. ఓకే, ఇందాక సల్ఫర్ ఆక్సీ యాసిడ్ క్లియర్ చేసాం. దెన్ నెక్స్ట్ అలానే రిమైనింగ్ నైట్రోజన్ ఆక్సీ యాసిడ్స్, ఫాస్ఫరస్ ఆక్సీ యాసిడ్స్, కార్బన్ ఆక్సీ యాసిడ్స్ అండ్ సల్ఫర్ బోరాన్ ఆక్సీ యాసిడ్స్ ఇవన్నీ కూడా ఒక్కసారి మనం డిస్కస్ చేసాం. సో ఫర్దర్ క్లాస్లో ద నెక్స్ట్ వన్ ద అప్లికేషన్స్ ఆఫ్ ఆక్సీ యాసిడ్స్ అండ్ అదర్ ప్రాపర్టీస్ we will discuss. So thank you.